Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta. A little while ago, we switched to co-hosting because Nicole got tired of talking to herself and the voices in her head became a little concerned. So, here I am, back for a 5th episode. And another voice in her head. And also on this podcast. But Nicole, in all honesty, why did you make the switch?
Well, I had done 26 episodes at that point. I really enjoyed the show. I really enjoy doing the research. I really enjoy sharing the information. I love nerding out about these topics, but it does get a little bit lonely doing it all by yourself. So I really wanted to have some collaboration, sharing some of the work, making the podcast a little bit more of a discussion style instead of just me talking into the microphone. And I think it's really provided a space for me to insert my own opinions, which has been nice. It's a little bit different when you're just talking to yourself into the microphone. It's harder to I found it harder at least to come across with a strong opinion, but as we're discussing it, I feel like it's just a lot lighter and it's a lot more fun to make. Plus, I really like some of the new ideas that you've brought in, like the fake ads that we've been doing, which are a lot of fun to put together, and I laugh the entire time.
They are very terrible.
I laugh so hard every time. It's a wonder I make it through recording it in one go because they're so stupid that they're funny, so funny. So that's been really great. So I'm really enjoying it. I'm liking where the podcast is going. I like what we've done so far, and I think we've done some really cool failures, and we'll continue to do so. So I hope you continue to join me for future episodes.
I always look forward to recording these and researching them and learning more about engineering failures that I didn't know about until I started researching them. But the good thing, for at least this podcast, is that there have been a lot of things that have failed over the last number of millenniums. So I don't think we'll run out of content anytime soon.
No, I don't think we will run out of content either. Also, thank you to all the listeners that send us content, which is hugely appreciated. And I love those little surprises in my inbox or on Twitter about different failures that are going on in the world and different reports that have come out. I really appreciate that. And I just end up in a rabbit hole in the middle of the day reading whatever was sent to me. So that's been really fun.
And we couldn't do it without our advertisers. So thank you to all of our advertisers that have sponsored us for the last 5 episodes.
Which ad's your favorite, Brian?
It has to be the Sit Down Stand Up Paddleboard Company. When I wrote that one, I laughed the whole time I was writing it. I think it's a really funny concept that you have a stand-up paddleboard that's made by the Sit Down Stand Up Paddleboard Company where you can sit down on your stand-up paddleboard.
And do you tell people about this in real life?
It has happened a number of times that I have recommended that somebody purchase a sit-down stand-up paddleboard.
That's awesome. And so silly. Okay, enough of that. So before we get into the news, we have a little update from a previous news article that we covered. The container ship Ever Given, which got stuck in the Suez Canal in March, has since successfully gone through the canal without getting stuck.
I read that Ever Given was impounded for 3 months until the ship's owners and the canal owners could reach a compensation deal after Ever Given blocked the shipping route for 6 days, which is a really long time to block a strait and a canal that is incredibly important to the movement of goods all around the world.
Yeah, I'm really curious. You know, I didn't know much about the Suez Canal, but I feel like after researching and learning about the Panama Canal that we did last episode, that I know a little bit more about canals than I did before. And I'm now thinking that 6 days of no traffic and therefore no revenue would have been quite expensive for the canal owners.
And also for the Ever Given, or the company that owns the Ever Given.
Well, yes, of course. So I just wanted to share that little tidbit. This week in engineering news, we're going to talk about improved electrical insulation. Insulation hasn't really changed since World War II, which is quite a long time ago when you think about it. But since then, there's more stress on the grid, we want faster processing, and we're even using electricity for transportation. There's a lot of electric cars going around, we've got electric trains, and there's other transportation applications that we could be using it for, but it's a lot more difficult at the voltages that we need with current status of the insulation. The heat these systems generate can cause them to fail over time, But we also have to protect from the weather. So it's not a simple problem. Researchers are looking for materials that can handle large electrical resistance. They can handle tolerance to extreme temperatures, mechanical stress, resistant to moisture, and also have a good thermal conductivity. So it's not really a one-size-fits-all problem. There's a lot of things that they're trying to cover. The University of Texas at Austin and the U.S. Army Research Lab are looking at new materials for insulation and packaging to remove heat more effectively. They've come up with a nano-composite material that's made from polymers with nanoparticles in them, and they have a better thermal performance than metals, but they're also lightweight, they corrode less, and they're easy to manufacture. The applications for this type of product are really endless, but some of the main ones that we can see are power grids, laptops, minimizing power plant cooling, and electrical aviation. It's really exciting to think about all the different advancements we can make if we can adjust the insulation to make it more effective. I think that's a really cool research project. I think it has a lot of wide-reaching applications that will affect all of us for various reasons at various times. So that's really exciting. If you want to read more on the study, head to failurology.ca and check out the link for this episode. Hey hun, I'm not sure if you know this or not, but Balls Falls Ostrich Egg Consultants has an exciting business opportunity for an excellent salesperson. Do you ever feel like you don't have enough excitement in your life? Balls Falls Ostrich Egg Consultants has an unlimited time opening on their team where you can make 4 figures a week. The first 3 figures are zeros. Don't put your head in the sand. You can be your own #Bosstrich babe. Now on to this week's engineering failure, the Transatlantic Telegraph Cable Failure.
Nicole, first off, what is a transatlantic telegraph cable, and is there also a corresponding transatlantic fax cable?
So the Transatlantic Telegraph Cable is, well, it started off as one, but now there's a series of undersea cables that run under the Atlantic or other bodies of water, although in this case specifically the Atlantic, for long distance communication.
And that's where all the cat pictures that I look at every day on the internet come through, right?
Exactly. Well, I mean, assuming you're not getting them from North America. The telegraph cables were initially intended to transfer communication such as Morse code or telegraph, but they've obviously since been replaced with data and telephone type communication cables. They're still widely used today. So, I mean, as much as we're all used to being wireless, the internet is really hardwired, which is such an interesting thing to think about.
Construction for the transatlantic telegraph cable started in the late 1850s, which was a few years before I was born. The date of its first use was August 16th, 1858, but it didn't last a long time after it initially started to operate. So it went from Valentia Island, Ireland to Heart's Content, Newfoundland, and its design capacity was 8 words per minute, which is worse than dial-up, and it's about as fast as some of the people I work with type.
Do you have 2-finger typers? They type with 1 finger on each hand. Do you work with those people?
There are a number of people I work with that use 2 fingers to type, and one person that uses 1 finger to type.
Oh, interesting. Did you ever have dial-up internet as a child?
I did, actually. I remember when I first got internet, and it was very slow internet, and then we upgraded to high-speed internet, which for the time it was very fast. It took 30 minutes, I think, for a song to download. A 3-minute song would take 30 minutes to download. The quality was terrible. We couldn't really stream videos.
Was that on Napster by any chance?
That might have actually been pre-Napster.
Whoa.
Yeah, I'm very old. So the operator was the New York, Newfoundland, and London Telegraph Company and French Atlantic Cable Company.
There were a few key players in this story. There's obviously a lot of people involved, but there's 4 key players that we're going to talk about the most. So we're going to let you know who those are first. So first we have Wildman Whitehouse. He was a medical doctor by training, but he had taken interest in the new electrical tech and decided to follow a new career path, which is great. Except he had no formal training in physics, and all of the knowledge he had related to electrical engineering and design was gained through practical experience, which for the 1850s, I think was probably somewhat standard practice in how people move throughout their careers. It's definitely different than today. We certainly didn't have the professional engineering structure that we have now. But and you'll see why as we get into the story, but I do find White House's lack of formal electrical training to be a bit suspect in how he ended up in the position that he did. And next we have William Thomson, and he was significantly undervalued, at least at the beginning of the project, and he was responsible for a lot of the testing equipment that was discovered. He came up with a new theory on how current degrades in transmission lines, and I mean, really a hero of this entire program in my mind. And then we have Charles Tilston Bright, who was the chief engineer, and Cyrus Westfield, who was the vice president of the Atlantic Telegraph Company.
Before they built the cable across the Atlantic, they had a number of issues to overcome. The primary one being that electricity and water don't really mix well together. And up until that point, there wasn't a really good material that they could use to insulate the electrical line that was both waterproof and was also not susceptible to pressure. Or in the mid-1850s, gutta percha, a material that was newly available in Europe from Asia, came to Europe, and that wasn't affected by temperature, or it wasn't affected by pressure. It was also waterproof. And so gutta percha is a natural thermoplastic rubber that can be molded once heated, and it will harden when cooled, which is perfect for this application of laying a cable across the Atlantic.
Also, that seems pretty advanced for the 1850s that they would have product or a material like this. I'm actually kind of impressed that they use this.
Yeah, I mean, they started to use it, in cables, at least in Europe in the 1820s. So they had a couple projects that were almost 500 kilometers in length. In the very early 1800s, which was a substantial way, or it was a substantial distance, I feel, for any project, especially a cable laying project back then. But they also had another issue. They weren't really sure where the cable needed to go besides between North America and Europe. So Field, who was the VP of the Atlantic Telegraph Company, he reaches out to Lieutenant Matthew Maury, who was the head of the Naval Observatory in Washington, who coincidentally had just completed a sounding survey across the Atlantic, across the North Atlantic, and had discovered that there was a plateau that ran across the Atlantic between Europe and North America that would actually probably be ideal for laying a telegraph cable. It was the soil was very soft, or the silt was very soft, so the cable could just be laid on top and it would just sink into the muck. And it was also raised quite a bit above the rest of the Atlantic, or the lower points in the Atlantic. So it would require substantially less cable than another crossing point. So this seemed like a very natural route to lay a cable across the Atlantic that would connect North America and Europe for the first time. But they did have competitors to this. So Western Union, that is still around to today, was a direct competitor of Field, and they had proposed a much shorter route, just over 80 kilometers, that would go across the Bering Strait from Alaska to Siberia. So although it was a much shorter route across the land versus across the ocean, they had issues in Siberia with a lack of trees that they could use for telegraph poles. So this created some fairly monumental challenges for them. So Field's route over time seemed to be the preferred route, or the one that made the most sense, although that wasn't without a lot of opposition from Western Union.
Interesting. I wonder what communication would look like today if the route between Alaska and Siberia had gone ahead instead of, or at least before, the transatlantic route. I wonder if that would have impacted how we communicate today, or who the major players are. Probably not significantly, but it's just interesting to think about.
I think it might have changed settlement patterns a little bit. Because you have to remember too, like they're laying this cable between two of the larger population centers at the time, between Europe and the northeastern coast of Canada and the United States. And there hadn't been a lot of development into the western part of North America at the time. So I think if the telegraph line had gone ahead through Siberia and through Russia, I think we probably would have seen a lot more development, or at least earlier development, along the west coast of the U.S., because this is pre-gold rush era as well.
Yeah, probably also the settlement along the northeast part of Eurasia, or what is now Russia. I mean, that area is very minimally developed even today. So I wonder how that would have impacted settlement.
Yeah, I mean, it is very cold there as well, and there's not a lot of resources that people can use to develop a civilization. But I do think it would have changed things if that was the route that did go ahead versus the North Atlantic route. It would have also, I think, split the shipping routes up quite a bit too, because there was still a lot of sea traffic and boats that were going back and forth between Europe and North America at this point. So yeah, it's interesting to think about what could have happened if the Siberia Alaska route did go ahead.
Yeah, it's just fun to speculate on how things could be different if 170 years ago they put the cable in a different spot.
Yeah, so they've picked this route out, and then how do they decide to build this cable across and underneath the water?
So, as you could probably tell from my previous mention of the various players involved in this cable laying exercise, I am a Thomson fan. I am not a White House fan. And you're going to see why. Hindsight's 2020, but strong Thomson fan over here. So he had predicted that the transmission speed would be very slow due to an effect called retardation. And he developed the law of squares, which is a transmission line theory that states that the current injected into the line by a step in the voltage reaches a max at a time proportional to the square of the distance down the line. So essentially, this would tell them how fast their signal would degrade based on the resistance of the cable and the length of the cable, which, I mean, again, for 1850s, this is a pretty impressive theory that Thomson put together. But White House disagreed. He had joined several underground lines together that were a similar distance as the transatlantic route, and he said, no, there's not going to be a problem. But what he didn't quite understand was that underwater cables were not fully comparable to underground cables. So Thomson tested a similar cable in an underwater storage facility, and he found a resistance up to a factor of 2. Thomson thought a larger cable was needed to mitigate the amount of retardation that they would see across the length of the cable run. But since White House was in charge of the electrical decisions and he wanted a thinner cable, which was also cheaper, that's what they went with.
Thomson favored a mid-Atlantic start with the two ships traveling out to each coast, which would cut the time essentially in half that was required to lay the cable. White House, on the other hand, wanted both ships to travel together from Ireland so progress could report back to Valencia through the cable. So one ship would go ahead, and then it would finish laying its cable, and then they would splice the cable onto the second ship, and then they would continue laying the cable all the way across to Newfoundland. White House, as the chief electrician, overruled the initial 1857 voyage. He was supposed to be on board the cable-laying vessel, but he made excuses to avoid being on the vessel. Eventually, Thomson was sent in his place.
Another win for Thomson.
He's had a couple so far on this project.
Oh, he's not even done yet. He's got more.
So much winning with Thomson.
Woohoo!
So Bright, the chief engineer, convinced the directors and the backers of this project to do a mid-Atlantic route for the 1858 voyage. So that's the one where the ships would sail to the middle of the Atlantic, and they both go opposite ways. So Field assigned Thomson and White House to two different ships to avoid conflict, but since White House never went, Thomson went alone.
So one thing, we're talking about the differences or their different opinions and what they were and who won, but it sounds like from reading there's a lot of drama going on between White House and Thomson because from, again, my Team Thomson bias opinion, Thomson is right about a lot of the stuff that he's saying and White House is just blatantly disagreeing with him and doesn't really seem to have the data to back it up. So there's so much drama between them that they had to be put on two different boats.
And the whole time that Thomson and White House are fighting and in conflict, Field is out trying to get investment for this project, this incredibly monumental undertaking that really for the time is probably quite preposterous. And it's a little difficult for him to convey how important this project will be for the development of the modern world to people that have never communicated, in a timely manner between Europe and North America. Because at this time, the only way that you could send a message between Europe and North America was on a ship. So we were talking about weeks for a message to get between, say, England and Washington. And Field is proposing this cable that will go underneath the ocean, that'll be laid from ships and allow transmission of messages within minutes, which is unheard of for the time.
Yeah, I think so. The ship route, I think it takes at the time took about 2 weeks to go from Europe to North America and then 2 weeks back. So if you had to deliver a message and provide a return message, you're gone for a month. Yeah, this cable, I mean, the first cable wasn't quite down to minutes, but definitely hours. It was less than a full day, which was huge. Huge. And that's just the time saving. But think about the cost. And we're going to talk about this a little bit, but you're saving, I mean, you have to send a crewed manned ship out for a month to deliver a simple message, or maybe a complicated one, but just to deliver a message and back. That's expensive.
Seems like a much simpler time. It's like I kind of wish that it was like that based off the amount of email I get in a day, but that was then and this is now.
Fair enough.
So they have 4 ships that are going to attempt this cable laying attempt from the middle of the Atlantic. So there's 2 British ships and 2 American ships, and they meet in the middle of the ocean, and it takes them a couple times to really get going. The cable breaks a few times. The first attempt that they make, the cable breaks when the ships are still within visual sighting distance of each other. So they try it a couple more times, and they return to Ireland to really figure out if they have enough cable to even pull this off, and if they have enough funding to make this happen. And so they decide, they do some calculations, they decide they have enough cable that they can make this happen, but just barely enough cable. So this is really their last attempt that they have to make this cable work. And surprisingly, on the 5th attempt, it works. They successfully lay this cable in about 2 weeks. They have this cable that's on the ocean bed that goes from Newfoundland to Ireland. And that's never been done before. So Europe and North America are now physically and electronically connected together. Over 3,000 kilometers, which when I think about it for the time, for 1858, like that's just wild.
I know. I was not aware that this happened that long ago until we started researching this. And then I was really, really impressed at the fact that they undertook this project, that they were eventually successful, the methods that they used, the materials that they used, really impressive for this long ago.
Yeah, so on the last episode, Nicole had mentioned that I'd done a hike that starts at the Mexico-US border and goes all the way up to the Canada-US border. So that hike's about 4,000 kilometers. So it's slightly shorter than the distance of cable that they laid, and it took me 4.5 months to walk that far. Like that's a lot of cable that they put between 2 continents in the span of a couple weeks.
Yeah, really impressive.
And so once this cable's laid, there's some fairly big celebrations that happen around the world, and there's congratulatory messages that go from Queen Victoria to the US, the White House in the US, and then a message that goes back. And people get so carried away celebrating the success of this cable being laid. Celebratory fireworks catch the bell tower of City Hall in New York City on fire.
That's not a good time.
Not at all.
The cable was laid, but now they had to test it and get it up and running and be able to test the strength of the signal across the cable. And Thomson wanted a better method of detecting that signal. So he developed the mirror galvanometer, which is an ammeter used to measure electrical current in a circuit. And this particular device does that by deflecting a light beam with a mirror. And it was a very sensitive instrument. He requested money from the board to test his galvanometer and build more, but he was only given about a quarter of what he requested, and he was only given permission to test it out on the next voyage. Turns out, his device was extremely good at detecting positive and negative edges of telegraph pulses that represented a Morse code style dash and dot, respectively.
Man, this Thomson guy is pretty good.
Yeah, Team Thomson all the way. So he believed that he could test low voltages from regular telegraph equipment, and he successfully tested it on 4,300 kilometers of cable in an underwater storage facility in Plymouth. For reference, the cable that they were installing was about 3,500 kilometers, so he tested a section that was quite a bit longer than the one that they installed. But, shocker, White House didn't like that method, and he wanted to use a high-voltage induction coil, which produced several thousand volts to create enough current to drive standard electromechanical printing telegraphs, which were used on the inland telegraphs. Thomson's instrument also had to be read by hand, and it didn't automatically record the message, which White House wanted. After all this, even though Thomson was merely an advisor, it wasn't long before all electrical decisions were deferred to him. partially because Whitehouse kept bailing on the voyages, and partially because Thomson had proven himself at this point.
Whitehouse drives 2,000 volts through the cable shortly after the cable had been laid on August the 5th and damages the insulation. So the press had been told the project was a success. The people believed the project was a success. Whitehouse says it's going to be about 5 or 6 weeks to do some adjustments on the cable.
Quote unquote adjustments.
Yes, adjustments.
Mm-hmm.
Whitehouse finally gives up on his own equipment and uses Thomson's mirror galvanometer, which works. But he took those messages and printed them out so it looked like the printing telegraph was working.
This is pretty shady. I mean, I know it's probably surprising, but I'm not a fan of this Whitehouse guy.
Yeah, me neither. The more we talk about him, the less of a fan I am of him.
Yeah, Team Thomson.
Yeah, all the way. And then ultimately in September of 1958, after progressive deterioration of the insulation, the cable fails.
So this is weeks, maybe a month after the cable was laid. This is not years. This is, a month. This is barely any time has passed and the cable has already failed.
It's a great success, and then it fails very quickly. I feel it fails very quickly even for 1858 standards. That seems like a fairly short failure period.
Yeah, so I mean, this isn't always the case, but if you ever wonder, I mean, projects get delayed, right? And people say, oh, we've got to make adjustments, we got to do this, we got to do that. But at least today, as far as public image, it's very important to test your product and make sure it works before you tell everyone that it works and before you roll it out. And if you need extra time to do that, that's a smart idea.
And it's not good if your product fails a month after it's supposed to start working.
No, and a very expensive product. I mean, I realize that they learned a lot, and so this is kind of the R&D phase, I guess you could say, but laying this cable was not cheap.
No, so back in $1850, it was around $1 million for this cable. So yeah, it's not cheap. It hadn't been done before, to at least this length. So it was a monumental undertaking, and they weren't really sure if it was going to work. And it failed a number of times before it worked, and then when it worked, it failed a month after it started working. But ultimately, Whitehouse is held responsible and fired from the project.
Oh, darn.
And Thomson, coming through again, he has to reconstruct what happened. So he figures out that the cable was the most vulnerable in the first 100 miles from Ireland. Not only was it too small, it was poorly manufactured. They'd used a different cable at first and then spliced into it to continue the installation. In some places, the conductor was badly off-center, so it could easily break through the insulation through mechanical strains during laying. It conducts some tests on samples of the submerged cable. When perfectly insulated, there was no problem applying thousands of volts, but a pinprick hole lit up like a lantern when tested and burned a large hole in the insulation. And again, this cable underwater, so if you have a hole in the insulation, this is not going to turn out well for your cable. So they did have some success, though, before the cable shut down. So there were 732 messages that passed through the cable before it failed, and it took about 17 hours to travel from one side to the other. So not super fast, but way faster than trying to pass messages via steamship at the time. So there's a couple significant messages that were transmitted through the cable. So one of them was the collision between the Cunard Line ships Europa and Arabia, and that was reported on August the 17th of 1858. And also the British government ordered 2 regiments in Canada to embark for England, saving $50,000 at the time, since they didn't have to send a ship with the message over to Canada that they needed regiments to embark.
But luckily for us, they tried again. And it took them until 1864 to raise enough money to do that, so about 6 more years. Honestly, after seeing the success and the potential savings of the first cable, even though it only worked for a month, I'm kind of surprised it took them 6 years to raise enough money.
Well, it was probably difficult to communicate between Europe and North America since, the cable didn't work.
Okay, fair point. In between 1858 and 1864, some cables had been submerged in the Mediterranean and the Red Sea, and they learned some things. So here's how they constructed the 1864 cable, which I think is a really interesting product that they made. So the core consisted of 7 twisted strands of very pure copper coated with a waterproof insulating compound and then covered with 4 layers of the gutta percha product, that natural thermoplastic rubber that we talked about before. And then they alternated with 4 thin layers of compound cement. Then that core was covered with a hemp saturated in a preservative solution, helically wound with 18 single strands of high tensile steel wire, and covered with fine strands of manila yarn steeped in a preservative.
This seems like a much better implementation of this transatlantic cable than the first attempt.
Yeah, definitely a lot more calculated in the method. I think the first, based on the fact that the core didn't sit directly center within the insulation or the protective coating, and among some other things, the cable was breaking as they were laying it, and it just not holding up very well in all. I think they learned some things, and they went back and built a much more robust cable. And robust it was. This thing weighed just under 1,000 kilograms per kilometer, which is nearly twice the weight of the old cable. So it's a pretty hefty cable. And the company that manufactured it made about 48,000 kilometers worth, which weighed 1,600 tons, and they made it in 11 months with 250 workers. So it wasn't a fast process, and it wasn't a simple process. It took a lot of effort to get this cable made. That's just the manufacturing, and then, of course, they have to lay it as well.
The SS Great Eastern steams from Valencia, fitted with 4,300 kilometers of cable on July 15th, 1865. On August the 2nd, after just under 2,000 kilometers of cable was laid, the cable snaps near the stern of the ship and the end of the cable is lost. On July 13th, 1866, the Great Eastern starts again, lays a new cable to complete the crossing, and reaches Newfoundland on July 27th, 2 weeks after they started, which is actually pretty fast to lay cable, I think.
Mm-hmm.
At 9 a.m. the next morning, England sends a message that says, "It is great work, a glory to our age and nation, and the men who achieved it deserve to be honored among the benefactors of their race." And in August, the Great Eastern and a couple other ships, they go in search of the lost cable to hopefully find it and splice a new cable onto it, or new end onto it, so that there'll be 2 cables that cross the Atlantic.
A needle in a haystack, if there ever was one.
That's like a needle in multiple haystacks. The cable, that's not a very large cable, and the Atlantic Ocean is quite massive. So yeah, they're looking for a needle in multiple haystacks and multiple barns. So this is not going to be the easiest thing that they're going to do. But somehow they find this cable.
And it didn't even take them that long.
On August the 10th, the Albany catches the cable and brings it up to the surface, where unfortunately it slips from the buoy that they put it in overnight, and this happens a few more times until September of 1866.
Which is not surprising, because it's been sitting on the ocean floor for over a year at this point, so it's probably got a bunch of slimy stuff on it.
Silt and whatever else is in the ocean that covers cables. But they eventually recover this cable and splice it into a fresh cable, where they sail to Newfoundland and arrive on September the 7th. So now they have not 1, but 2 working telegraph cables going across the Atlantic.
This is really impressive. We're reading this is in the past. We know obviously they were successful eventually, but you're still rooting for them. You want them to succeed. And I'm really glad they kept at it and they didn't just give up after the first attempt. I think it took them,
or the second attempt,
or the third or fourth or fifth. It took a while, but they got it. So the original telegraph cables, of which there were more than just these 2, were eventually made obsolete and replaced with telephone and data cables that still exist today. And at this point, there's an estimated 380 underwater cables in operation around the world, and the total length of all of them is about 1.2 million kilometers, which is an extensive cable network. Some of these cables are funded by Facebook, Google, Microsoft, and Amazon, which, if I'm being honest, is maybe a little concerning. I honestly thought, I don't know about you, Brian, but I honestly thought we were using satellites at this point. I mean, everyone's on Wi-Fi. Nothing's hardwired anymore, at least in my own little bubble. I just assumed that we were sending signals to a satellite that was then directing it back to wherever we're sending the signal. I had no idea we were still using this many cables. I feel a little silly now, but yeah, no idea. Hurricane Sandy knocked out several key exchange links in 2012, and there's actually about 200 cable failures that happen every year. A lot of them are caused by humans. So there's fishing nets, sometimes a ship anchor runs into it, but then sometimes there's earthquakes or underwater landslides. So, there's a number of reasons that these cables fail.
And also, sharks like chewing through the protective coating sometimes.
Oh, do they get electrocuted when they do that?
I'm not actually sure. I'm not a shark biologist.
That would be sad if they did. They don't know what they're chewing on. It's like when your dog chews your phone cord. It doesn't know that it's plugged in. It doesn't understand electricity.
If anyone's a shark expert, let us know if the sharks get electrocuted when they chew through the protective coating on the cables.
Yes, please do. I'm curious. Luckily, the cable owners or providers, they use multiple routes. So when one cable is knocked out, they just reroute your communication through another cable. And we never really noticed the interruption on a personal level. I'm sure if there was a large grouping of cables that were knocked out or compromised, then perhaps we would notice. But for the most part, there's enough cables around that they're able to reroute our service, and we're none the wiser. Interesting on that note, tapping into these cables is even a form of espionage. So the US did this for about a decade during the Cold War, but they weren't the only one. The UK has been accused of it. I believe Russia as well. And then there's some concerns that Huawei, who wanted to build cables, would also potentially be tapping into those cables. I mean, at this point, Huawei would own them, so it's a little bit different. But, using that data for their own uses, whatever those may be. So that was really interesting. I hadn't really considered that. We put all these different firewalls and these different things to protect our data, but this seems like a weak point, and this seems like we have an unfortunate exposure that maybe could be better handled.
So, there you have it. We tried not to string it out too much. They got off to a rocky start, a little drama, but they eventually turned it around, and a decade later they had 2 working cables. And now we can all look at cat pictures on the internet at work.
How many cat pictures do you look at?
At least 1.
Oh, that's not so many. Dog pictures?
Way more than 1.
Yeah, I'm a dog person too. For photos, sources, and an episode summary from this week's episode, head to failurology.ca. If you're enjoying what you're hearing, please rate, review, and subscribe to Failurology so more people can find us. And if you want to chat with us, our Twitter handle is @Failurology, or you can email us at thefailurologypodcast@gmail.com. You can also connect with us on LinkedIn. Check out the show notes for links to all of these. Thanks to everyone for listening, and tune into the next episode where we'll talk about the Montreal Olympic Stadium, or more commonly called the Big O. As far as engineering failures, this one might take the cake. Bye everyone. Talk soon.
Oh, sorry. My dad just texted me.